The issuance of China's first commercial satellite mobile communication license marks a pivotal shift in the nation's space-based communications infrastructure. On September 8, 2025, the Ministry of Industry and Information Technology, MIIT, granted China United Network Communications Corporation, China Unicom, the official permit to operate services such as direct-to-satellite mobile connectivity, emergency communications, and maritime communications. This regulatory milestone follows closely on the heels of MIIT's policy guidance, released just over a week earlier, signaling a coordinated effort to accelerate the deployment of low Earth orbit (LEO) satellite networks. This move elevates satellite communications from experimental initiatives to full-scale commercial operations. The Chinese government has set an ambitious target. By 2030, the country aims to support over 10 million satellite communication users, with direct-to-satellite mobile services becoming a mainstream offering. This vision reflects a broader strategic realignment, positioning LEO satellite systems not merely as supplementary tools, but as core components of national digital infrastructure. Policy reforms are reshaping the industry landscape. Historically dominated by state-owned enterprises, the sector is now opening up to private participation. The new guidelines distinguish between different types of licenses, a 13 for mobile and a 23 for fixed satellite services, and explicitly encourage private sector involvement. While only a handful of major telecom firms currently hold A13 licenses, this evolving framework creates opportunities for private companies to contribute across the supply chain, particularly in hardware development and ground equipment manufacturing. One of the most significant drivers of progress is the rapid pace of satellite deployment. The state-backed China Satellite Network Corporation is overseeing the GW Constellation project, which plans to launch nearly 13 satellites. Since mid-2025, the launch cadence has increased dramatically, from once every 1 to 2 months to every 3 to 5 days. As of August 2025, 72 satellites had already been successfully placed into orbit. Private aerospace firms are also advancing reusable rocket technologies, with models like Tianlong 3, Smart Dragon 1, and Zuki 3 expected to debut before year-end. If successful, these developments could slash per kilogram launch costs from tens of thousands of dollars to under 500, easing constraints on large-scale constellation builds. Manufacturing processes are also undergoing transformation. Companies like Galaxy Space and China Academy of Space Technology are adopting standardized production methods that reduce the cost of key components, such as phased array, antennas, and baseband chips, by 30% to 50%. Meanwhile, ground terminal manufacturers, including Chuangyuan Xinkei and Shanghai Huantong, are rolling out 5G NTN-compatible chips that are smaller, more energy efficient, and better suited for integration into consumer devices. The next few years represent a critical window for China's LEO satellite ambitions. Two major constellations, the GW and Qianfan projects, are expected to deploy over 25 satellites collectively, requiring an average of 3 launches annually through 2030. This surge will stimulate growth across the entire aerospace value chain, from raw materials to launch services. Beyond infrastructure, the true potential lies in application scenarios. Direct-to-satellite mobile services are projected to become the first mass-market use case, with China Unicom reporting promising early test results. Data speeds of up to 20 megapaces and latency under 100 milliseconds. Forecasts suggest this market could generate revenues exceeding RMB 100 billion annually by 2030, with user spending nearly double that of traditional cellular services. Other emerging applications include connected vehicles and low-altitude economy platforms. In February 2025, China Unicom conducted a successful field trial using Geely's Future Mobility Constellation to enable vehicle-to-satellite communication, demonstrating coverage capabilities in remote areas where terrestrial networks fall short. Local governments in regions like Hainan and Chengdu have begun investing in satellite superfactories and reusable rocket facilities to support these initiatives. Satellite-based Internet of Things, IoT, is another promising frontier. In Inner Mongolia, for example, satellite IoT systems are being used to monitor livestock health and location in real time. Similarly, power grid operators are leveraging satellite links to manage substations in isolated regions. Compared to terrestrial alternatives, satellite solutions offer up to 60% lower deployment costs in sparsely populated areas. Despite rapid advancements, challenges remain. Regulatory clarity for private operators is still limited, and further cost reductions, particularly in terminal hardware, are necessary to achieve widespread adoption. Internationally, competitors like SpaceX's Starlink and Amazon's Project Kuiper are expanding rapidly, putting pressure on Chinese players to scale globally. As the ecosystem evolves, collaboration between public and private sectors will be essential. The convergence of policy support, technological innovation, and market demand is setting the stage for a transformative era in China's satellite communications industry. With foundational infrastructure taking shape, the focus is shifting toward building sustainable business models and delivering tangible value to end users.